So I got a truss bridge diagram here, and we are basically what we have to do is we have to determine the forces that are experienced within each member of this trust. Okay. So first thing in truss analysis that we do is we have to figure out the reaction forces, or so to speak, in of the supports here at point A and point G of the bridge. So we have an external force of 20 kilonewtons and 30 kilonewtons. So the first step that we usually do is we draw a we do a free body diagram. So that's like just looking at the whole body, the overall body of the whole thing, and what external forces are being applied on it. We have the force up here, which is 20 kilonewtons, 20 kilonewtons, and we have another force here, which is 30 kilonewtons. And we have our reaction forces at A, force in the y direction, y-axis of A, and we have Fxa. We got here Fyg and Fxg. Yeah, so we got our external forces to deal with here. Since we know that this whole bridge doesn't move anywhere, we know that the sum of all forces in the y-axis is equal to 0. So what are all our forces in the y-axis? Let's just have our notation for our reference as up is positive, and we have across to the right is positive, and let's just do clockwise is also positive. Yeah, okay. So sum of forces in the y-axis is 0. So what are our forces in the y-axis is just right underneath. We have Fya, we have 20, we have 30, and we have Fyg. Now we predetermined or had the notation that upward is positive, so we have Fya plus Fyg minus 20 minus 30 is equal to 0. So that we end up knowing that 50 kilonewtons is equal to Fya plus Fyg. Does that really tell us anything? Not really. So what we can end up doing is we end up using, the sum of all moments is equal to 0 because this object doesn't rotate anywhere. So we end up, let's just say the moments at point A is equal to 0 because the object doesn't rotate around the point A. So let's see, what forces do we see here? We have 20 kilonewtons. We project it down here, right angled. And now let's see, what's this distance? Because moments or rotational force is equal to the linear force multiplied by the distance. Each equilateral triangle has a side length of 1 meter. And we know that this is a 60-degree triangle. You can already predetermine that this is half the length. It's going to be 0.5. So we end up with 0.5 times 20. And we determine clockwise is already positive. Plus, let's see, we have 30. And that is what? 1, 2, 2.5. 2.5 times 30. Yep. And then to balance this all out, we have our Fyg, which pushes back, minus Fyg. And this all equals 0. So we know that Fyg is equal to this thing. 0.5 times 20 is 10. 2.5 times 30 is 75. So which makes 85. Now we can just plug it back into this equation. or we can independently solve for the moments around point B. I mean, not point B, point G. And then we can end up just doing the same thing, but it's easier just plugging it back in. So 50 is equal to FYA. Wait a minute. Oh, okay, wait. My mistake. Okay, so FYG. My apologies. So the mistake that I made is that it's FYG multiplied by the distance. So this total distance, which is equal to 3. So FYG times 3. Right? Moments is equal to force times distance. So we end up with 75 over 3. 3 FYG is equal to this, which is equal to 85. So FYG is equal to 85 over 3, which is, let's see, 85 over 3, 28.3 repeater newtons. Yeah. So now I just plug this back in, which makes 50 minus 28.3 repeater. So 28 and a third. 28 and a third. 65 over 3, which is the same thing as 21 and 2/3. So FYA is equal to 21 and 0.6 repeater newtons. Not newtons, kilonewtons. Kilonewtons, yeah. Okay, so now we found our forces of our reaction forces up here. So let's just replace them, just rub this out easily. Okay. So then we end up with, just substituting back in. So FYA is equal to 21.6. This is 28.3. Yeah. And our FXA and FXG, there's no horizontal external force, so these values actually end up equaling 0. Because if there's a horizontal external force, then these actually come into effect. Okay. So next, what do? We found our forces. It's red now. So this force is now, what was that again? Being 21.6. I'll just round it now, 21.7. And this force is 28.3. Alright. Now, using the method of joints, how are we supposed to figure out all the forces experienced by each of the members? The idea is that we isolate each of the points or the joints, because it's, the method of joints. So the idea is we isolate each of the joints, and we know that for each joint, all the forces must equal to 0. So if all the forces equal to 0 at each point, then we can determine the forces that exist within each of the members. We usually start off with, this method is best when you have 2 or 1 unknown force. With 1 unknown force, it's not hard to get, but with 2 unknown forces, it's much more practical, and it's useful for 2 unknown forces. Alright, so first we determine the force at AB. So I'm just going to copy this diagram. Forget the text. So copy, paste. Alright. Yeah, forget the text. Okay, so now at AB, we're going to isolate at the point A. So I'm going to only look at, actually I'll just do it like this. I've got point A, and I got my line, one line here, and I got another line here. That's all I'm concerned with. I'm not concerned with anything else. Okay. So at this point, I have the forces 21.7. So I have 21.7. And I have these 2 forces. One going this way, and if I'm going this way, then it's fair to presume that this force is going this way. Okay, so now we know that the sum of all forces at this point is equal to 0. So let's see, sum of all forces at point A. So forces at point A is equal to 0, which is equal to 21.7. Wait a minute. Sum of all forces in the x direction is equal to, sorry, I have to separate this into x and y axes. This is 60 degrees. Yeah. B, C. Anyway. A. Alright. Just for our rotation. Anyway. Is equal to, in the x-axis, we have AC. And I have minus the cosine of, AB cosine of 60. Because it's the horizontal component of this diagonal force. And now this doesn't really tell me anything, so let's try working on the sum of all of the forces at point A, the y-axis. It's I have 21.7 minus the sine AB sine 60. Does this tell me anything? Yes, I can solve. Is equal to 0. It's also equal to 0. Yeah, now I can solve for AB sine 60. AB sine 60 is equal to 21.7. Divide by sine 60 because sine 60 is just a constant number. AB is equal to 21.7 over sine 60. Just using a calculator. 21.7 divided by sine 60. And I end up with, I'm just going to round here, 25.06 kilonewtons. So that I just determined the tension in force in the member AB as 25. One minute. Sorry, my pen just ran out of battery. Yeah. Okay, so we just determined that this is 25.06. What? Okay, it works. 0.06 kilonewtons. And then what? Okay, so now let's try solving for AC. Now we know that AB is equal to this. Now let's try solving F. Okay, just working across here anyway. This, just bringing it up around here. Okay, so then AC is equal to 25.06 cos 60, which is equal to, what do we end up with? We end up with 25.06 cos 60 is equal to 12.53 kilonewtons. So now we determined the two forces here. It's 25.06 and 12.53. 25.06 and 12.53. Okay, so now up here, let's try solving for this force. Let's see, do we have any point where, okay, we have a force that goes this way, we have a force that goes this way. Okay, so then let's see, we have 3 unknowns at this point. At this point, how many unknowns do we have? We have one known, 2 known, and we have 4 forces overall. We have 2 unknowns at this point. So let's try solving for point B. Point B, I'm going to isolate that point. We end up with one that looks like this, cross, and down, and the force that goes this way. So this we already determined as going this way at 25.06. Yeah, 25.06. This vertical force is 20. Yep, 20. And now let's just try determining these other 2 points. So the sum of all forces in the x direction won't give us anything because we have two unknowns in the x direction. Let's try doing the y direction. So in the y, for point B, so point B, y, FBY is equal to 20, minus 20, sorry, minus 20, minus 25.06 plus this. So let's see, this point is now B, and this is C, so this is B, C. So plus BC, yeah, plus BC, not BC, plus the sine of BC, is it? BC, yeah, BC sine of, yeah, sine of 60, which makes a 0, obviously, and then we bring the 20 and the 25.06 around, and we end up with BC sine 60 is equal to 20 plus 25.06, now, which is equal to 45.06. Now let's just divide by sine 60. So BC is equal to that over sine 60. Let's see what we end up with. 45.06 over sine 60. 52.03 newtons. 50. 52.03 kilonewtons. So this is 52.03. Now let's try FB. Sum of forces at B in the x-axis, FXB or FBX, doesn't matter really, but okay, this is just my naming, is equal to, let's see, all our forces in the x. So we have an x component from this BC, we have an x component from 25.06. This upwards external force doesn't have a horizontal component, but this does. So we end up with 25.06. Let's see, sine or cosine? It would be the cosine of 60. Usually cosine is related to the x and the sine is related to the y. Usually, not always. Plus, wait, no, this is the minus now, right? Because we're going opposite direction to get the direction correct. Because these are all vector quantities. Minus the 52.03. This is the cosine of 60. Plus BD. No, BE. Yeah, this is, alright, BD. My bad. BD. Then what do we end up with? We end up with BD is equal to, now we bring all these to the other side, we end up with 25.06 cos 60 minus 52.03 cos 60. So let's see, what do we end up with? I'm just going to factor out cos 60 here. So we have 25.06 minus 52.03 groups of cos 60. Just type this up. 25.06 minus 52.03 cos 60. This equals minus 13.485. Minus 13.485. Wait, if it's a minus, this is supposed to be a plus here. Bad. It's also supposed to be a plus here. So I made a miscalculation. Plus. Okay, so this gets us, instead of 13.485, we end up with, because that doesn't make sense, 38.545 kilonewtons. 13. So up here we end up with 38.545. 38.545. And BC we determined is 52.03. 0.03. Now let's see. At this point C, we have 2 known values and we have 2 unknown values. So let's see, what do we end up with? Let's try isolating point C. Isolating point C, we end up with a point here, point across, down like this. This is 60 degrees. And we have another point like this. Who knows which way it goes? Probably, my guess is this would end up going this way and this would end up going the opposite direction. The reason why I think so is because there's a down, so there has to be an up kind of thing. So it would have to go that direction. Anyway, let's try getting this done. Oh, wait. Whoops. So this is the directions I just notated wrong. Just get the directions correct. So let's see, across, down, okay. So then this is down, what? Did I write it down? No, this is up. Right, so this is not down, this is up. Yeah, that makes sense. So this is also not down. This is just up. Sorry for my mistakes. This is just up. Okay. And we have one force here and another force, so I'm guessing this is down. And this would maybe, I mean, it probably is across. Well, let's just see anyway. So this is 52.03. 52.03. This horizontal force is AC, right? AC is equal to 12.53. 12.53. And now I have these two forces. Let's see what we can do now. I mean, in most cases, if we were to do like a graphical solution, then we would end up doing force polygon, and then we just simply measure the sides. It would be much easier in this sense. But anyway, the sum of all forces in the y forces point C, y, because we want y because there's only one force in the y axis, which is equal to, now there's up, so there's 52.03. Is it sine or cos? It's now sine 60. Now minus, we have this force, so this is CD, sine 60. Now let's see what we can do is, okay, is equal to 0. So then we bring that around, and we have CD sine 60. CD sine 60 is equal to 52.03 sine 60. Divide both sides by sine 60, and we end up with CD is also equal to 52.03. Ooh, this is quite odd. But let's just see anyway. Yeah, that makes sense anyway, yeah. So this is also equal to downwards 52.03. Now thinking similarly, if I'm working at this point, then this would also be 52.03. I'm guessing, but like, let's just work that out as well. Anyway, let's see. Now let's just find this remaining force. Remaining force, okay. Yeah, let's just keep that as our last force that we're working on because it's getting a little tedious. So this last force over here, this horizontal component. So the sum of all forces in the at point C in the x direction, x dimension, yeah, is equal to 12.53 minus the minus 52.03. Let me just write that properly. 52.03 cos 60. Then we have this part here, so minus CD, so again 52.03 cos 60 plus, or minus anyway, plus this last bit, which is CDE. CE. Let's see what we end up with. Now this is just two groups of the one thing, so let's just bring it around anyway. So 12.53 plus CE is equal to 2 times 52.03 cos 60. Cosine of 60 is equal to 0, so I can just, not is equal to 0. The cosine of 60 is equal to 0.5. 2 times 0.5 is already 1. So multiplying those, they actually end up cancelling out. So I end up with something rather simple. Now let's just end up subtracting. CE is equal to 52.03 minus 12.53. 39.5 is the horizontal, not the horizontal, the force at this point. Not at the point, at the member. 39.5.